Hey guys, welcome back to the channel. Today we'll be working on HackTheBox Academy buffer overflow for Linux. Previously, I uploaded a video on Windows buffer overflow. So same from Academy HackTheBox. So if you want to check that out, you can go to my channel and watch that as well. So let's begin. So this is the buffer overflow page first and the basics. So I'll be covering the final skill assessment part, and you can cover all other previous steps on your own. So we'll begin with the introduction fundamental exploit. We'll begin with take control of EIP. So I have connected to the box. So in the final skill assessment, um, it says that there is a leave underscore msg file um, on the stb student profile this leave underscore msg, and this file is used to send message to the root, and it has suid bit enabled. Yes, so um, we can get a previous using this binary, and we need to read the root flag. And there are some questions that we need to answer, like determine the type of leave message binary. So this is easy, 32-bit or 64-bit. Then how many bytes in total must be sent before reaching EIP? We will figure this out and submit the size of the stack space after overwriting the EIP. The format is this, and then the final flag. So all these things we need to find out. So um, I've created a little notepad here just to take some notes. So first thing first, we need to use uh, GDB tool. So GDB minus Q leave underscore message. Um, okay, and then here we need to check with 1200 values whether that is crashing or not. So not it has not crashed, so probably we need to try with maybe, let's say, 2000, and still not crashed. So let's try with 2500. Now we can see it has crashed, so we need to lower some values, for example 2200. um, Restart, yes, crash. So it is less than 2200 but greater than 2000. So in order to find out the exact value, let's use the metasploit tools. So user share metasploit framework, and then tools exploit pattern create, and then length. Probably let's try 2100. Yes, so it is crashing. So let's try with 2100, and um, let's dump it here. And then this is the pattern which we will use, and here you can see that we are in 4 registers. We are able to override the EIP and EBP both using 55 bytes, um, the ASCII characters. So this is the illustration, and determine the offset, create it, and then run it using um, this command. So let's do that and copy paste and single double and then bracket close, enter, restart, yes, um, enter, and let's check info registers. uh, I believe something has happened. Let me increase the size, copy. Maybe I was not able to copy the whole thing, and then run dollar python c for command print single paste double quote close, enter, yes, info registers, and it is overwritten, and we can see that this was the um, value which we need to use to identify the offset using pattern offset. So we will run the same Metasploit tool, but the different tool actually, offset and query, and then the address. So exact match found at offset 2060. So one answer is 2060. I think this was the question. Um, yep. How many bytes? Right. So then they submit the size of the stack space. Okay. Let's move further, and we can take a similar approach which is used in this academy to uh, send our payload of 2060 and then the 4 bytes for EIP to overwrite the EIP. Paste, restart, yes, info registers, and you can see EIP is overwritten using 66 number, 4 bytes, so 8 times 6, and the EBP is still overwritten by with 55. So the calculation is absolutely correct, and we can move forward from here. And um, if you are wondering how to check the stack size, we can identify it using wait a minute, what was that? Info info proc all. So this is the stack, right? So for example, in the left, you can see the address range, the starting address and address, and this is the size, and uh, this is where the stack is getting finished, right? So you can put that value as an answer. So I'm quitting from here. Okay, and moving forward with the next step. So next is determine the length of the shell code. So uh, in this case, this 32-bit file is this. I think we can check using file command, and uh, the the shellcode generation command will be same. So I'm just copying it, paste, and we need to connect it locally on any port. So elite port is selected here, and the architecture is x86, format is C. So we can try executing this. How many total bytes, what will be the size of the shellcode, and then we need to uh, take some notes based on this approach, right? So, so uh, this is 2064 in our case, and then 100 we are considering as NOPs, no operation addresses, right? And then some size of shellcode, and the 4 is for um, EIP. So NOPs will be this, uh, and shellcode number we are waiting for that, and then 4. So it is taking few seconds. I'm pausing the video. Let's wait for the answer. Okay, so no need to wait. 311 bytes. This is the size of C file, but the payload size in bytes is 68. So we'll keep the buffer and we'll keep this to 150, um, and this number will remain 150. To 2064 minus 100 minus 150 minus 4 is 1810. I think now it's correct, 1810. Okay, all other numbers will remain the same, and now let's move further and use this calculation in GDB. So let's use, maybe let's copy this one, it will be much easier. So copy and paste 2064 here, 100, 150 minus 4, and then um, uh, NOPS addresses, right? So these are the NOPS addresses. Then shellcode, we are using 44 as of now, and then 66 for controlling the EIP. So let's verify it. Control C, paste from the beginning, yes, and info register. So you can see the EIP has been overwritten using 66. So this is absolutely correct. And now let's move forward. So next is identification of bad characters. So this is null byte. I mean, these are the most common bad characters. So this is the character list. Let's copy it. Copy, paste on my Kali Linux box. Enter, and then calculate the character length. Copy, paste, enter. It is saying 1. So there is a problem with the current Kali version, so it is not able to calculate the exact same thing. I found the alternative on the Kali box, but it is not handy with me as of now. So we will uh, quit from here for now, and we'll run similar, I mean the same thing on our HackTheBox. So let's try copy, paste, enter. And if I run this now, so it says 256. So total 256 bad character length is there, right? So it says 256, and then If we scroll down, so we need to calculate the buffer again, 256. So let's copy this, and I'm not making changes in the original one because sometimes we need to refer back. So 2064 minus 256, right? So you can see 250 was already there, and if we remove 6 from 1810, it will be 1804. Yes, and there will be some characters, and then EIP will be there. So let's paste it here. um, some characters in double quotes, right? Copy this as well because this is the calculation, but we need to execute this whole thing, right? So 256 minus 4 plus, so we are replacing all of this with those characters. So now I will copy this with double quotes, right? And I need to paste it here. So if everything is okay, not here. um, gdb minus q and paste it here. We need to check the main function first and set some breakpoint, right? So um, let's increase the size, scroll down, and the main function is this, where it is calling, right? So we will set the breakpoint um, at this address or at this function, right? So break, paste, enter. Breakpoint is set, and now we will send the characters again. So copy. I'm not sure if I can use the history. Yes, I can. Enter. Breakpoint uh, hit, I guess. Yes. So after we have executed buffer with the bad characters and reached the breakpoint, we can look at the stack, right? So let's see the stack. So copy, paste, enter, and we can see 55 byte is written in the same example as we are. So it is ending here, right? And in our notes we can see that we passed x55, then the all the characters below, and then the EIP. So the characters started with 000102, but if you look closely, the character has started from 01 because the 00 is a null byte and it uh, has ignored it. So this is one of the bad character, and I think I missed that part. So this warning came in our execution as well, ignored null byte in input. And then if we check further, and you will be able to spot other issues. So one is this for sure, the 0 and then the 1 2 3 4 5 6 7 8, and 9 is missing, and before BA should come. So A 9 and A is 9 and A are missing along with the null byte. So 3 are there, and then if you find out, then uh, you will see that 20 is also missing, right? And so these are our final bad characters. I'm just taking a note here. So one is um, 0x. Actually I should write it in some useful format, slash x 01, right, comma, not comma, slash x 00, x 09 slash x 0a slash x 20, right? So 009 uh, a and 20. I think that's all we need for now, and we can try removing these addresses from this command immediately. One is this, and then two consecutive characters, and then 20, and since we have removed 4 characters, um, we have reduced our shellcode with a count of 4. So let's minus 4 from 256. So run, paste, enter, yes, info register, and let's check the bytes now. I think it will be okay as of now. Uh, yep, 1 2 3 4 5 6 7 8, and then BC. So we don't see any null byte here, right? So we should be good now. So moving further, scroll down, characters, notes, removed bad characters, the stack, subtracted the bad characters, and we have sent without the bad characters, and then we can execute the next step, getting generating the shell code. For that we need to switch to Kali again, and the shellcode generation will be similar to this, right? We need to keep in mind the architecture, platform, and the bad characters. So we have used the same thing previously, right? But let's copy it again, paste, and uh, let's use same port 31337, 127.0.0 would work. 0.1 format C, architecture is same, platform is Linux, and bad characters here. So bad characters we already know. um, these are the bad characters. Enter, and then the file name. So they have used the file name as shellcode. Let's use that. It does not matter although. And the shellcode will look like this, and we will adjust the um, buffer using the generated shellcode. So I'm removing this part just to create some room here. So snipped. Okay, shellcode has been generated. So, and the size is 95 bytes. So um, let's copy the original one, paste it here. This is NOPS, this is shellcode, and we know our shellcode is 95, right? 95. And let's see what is the final number buffer. 2064 minus 100 minus 95 minus 4, that is 1865, right? So let's copy this shell code. Okay, and actually let's go to nano first, and I need to remove these inverted commas. I hope I will not mess this up. Yes, save. If I print this, I'll be able to put in this format. So here, right? So let's change the number. 2064 minus 100 minus 4, um, and then the minus 100 and minus 95. So the same value will go here, and then here the shellcode will go, and then the 4 EIP. Okay, let's copy that. Copy this, and before executing, I just checking whether we are on right track. Yep, so they have executed it using the shellcode 95. So it is same in our case as well. Paste, enter from the beginning. Yes, and let's move further, and we can check the stack as well, but let's move ahead. Identification of return address. We need to check the values. Uh, so press enter. So you can see the buffer is ending here, and from this part knobs is getting started till here. Yep. So we know the knobs address, and you can this illustration is very important. So we need to point the EIP address to this address. So we can pick any address from here. It is not necessary that we need to enter the first one. So somewhere in between, and knobs address means that no operation will be executed, and it will keep on executing this, and then it will start this. So our objective is that this shell code uh, part should get executed, right? So you can see in this example they have taken this memory address D4C, so exactly the next one, right? So from where the knobs address has started. So we can also pick this one, that's not an issue. So copy, paste, right? So next is to use this address of the EIP. So there is a certain method to write down this address. So first is we need to start from right hand side. So in their example you can see the address was this, and they have written 4C, then D6, then FF and FF. So from right hand side to left, but with the pair of two digits. So it will be written as X DC X D6, then X FF X FF. So this is the EIP, right? So we will replace this with this one. So let's copy this, paste it here, and replace this with this one. And similarly the final execution, not final, but in this execution we need to replace the EIP part till here, paste, and I think we are good to execute it. And one more important thing, that the address which we are using for EIP must not contain the um, bad characters. So in our case bad characters were 00, 09, 0A and 20. So all those addresses are not here, so we are good. So make sure that you are checking this thing. So we, before we execute, because this is the final shell code, we should be ready to receive the um, netcat session back. So in the shell code we have mentioned the 127 IP address, so we need to go to that server and we need to set up a netcat listener. So I'll take this session again. So stb hyphen student and at IP address of this box, paste, so copy, paste, and here let's set up NC and LVP 31337, the port which we have mentioned in the shellcode uh, MSF console command, right? So session has started, and let's quit from here. Yes, and we need to execute our uh, message in a format where we can supply the um, shellcode. So leave underscore message dot slash leave underscore message dollar python hyphen c for command print space then the complete message. So let's copy this thing, and from bracket to bracket let's paste it here. I think this is good. If I have not made any error, then we should be receiving the shell instantly. Yes, so connection is received. I hope this is root. Yes, this is root. So we should be able to read the flag which is placed in root flag.txt. So let's see ls slash root slash flag.txt. It is there, and we can read it. So I'm checking the word count and not reading it as of now. So 36 characters are there. So we can read the flag using root, and this buffer overflow execution was a success. So you can put the flag and submit it when you be able to read this. And the step-by-step instruction is good in this lab. So if you will closely follow everything, you will be able to finish the skill assessment part. So the exact step which we need to follow is in the exploit section. So I hope you have learned something new, and if you were making any mistake, you might get some clue from my video. If so, please like the video and subscribe the channel and keep watching other videos. I will keep posting hack the box and try hack me challenge videos. Thank you. Have a great day. Bye bye.